Hello, can you all hear me? Okay, that's good. Then I guess let's get started. Well, so this is my first stream, so might not run smoothly all the time, but let's see. So first up, a little motivation. So I recently made it so that the internal faces of the trees are drawn, and that makes everything kind of expensive, but it's also looking really nice. For comparison, here's how it used to look and here's how it looks now. So it's looking a lot better, but it comes at a heavy performance cost. Like for example, if we go over here to this forest biome, then you'll see that the number of faces drawn climbs rapidly. And yeah, that's not good. And the performance is also relatively bad. If we look over here, then it takes like 15 milliseconds per frame and at a relatively small render distance. So yeah, that's kind of the problem that I have, and I would like to solve it with GPU-driven rendering. Also, just to make sure, are you still hearing me? Okay, that's good. Wait, what? Huh. So yeah, also if you have any questions along the way, feel free to ask and I'll try to answer them. Well, honestly, there are already quite a lot of people here, so... Well, 10 people, but... The thing is, if I wait too long, then everyone else will be bored, and that's also not good. Okay, already a couple of questions. Do you plan on expanding the networking solution, or are you happy with what you have, aside from the bugs? Well, I am pretty happy with what I have right now, but I think there are a couple of areas where it could be improved. Now you might consider these bugs or new features, I guess, but there's definitely some work left to do there. I probably won't restart from scratch, but well, I will make a few changes probably. Are you coding your program for multi-platform? Yes, I am. In fact, let's try the Windows version real quick. So this is compiling the game for Windows, and then we can use Wine to run the Windows executable. And here you go, Cubyz on Windows, kind of. So yeah, it's definitely multi-platform. And I would also like to support macOS in the future, but that's kind of problematic with OpenGL. So we'll have to see how the Vulkan rewrite goes when I get to there. Well, my code only looks clean because I hid all of these functions here. If you look inside of here, then it starts looking less clean. Yeah, that's the default theme from Visual Studio Code. Alright, so the thing that the first goal would be to use glMultiDrawIndirect indirect. Indirect. Cubyz is not using software rendering. It is using normal rendering is like you have a bunch of draw calls. Like here I have this glDrawElements call. This gets executed on the GPU, but for every chunk mesh that I have, I need to execute this once on the CPU. So I have like a couple thousand or maybe even 10,000 of these draw calls on the CPU, and that makes it or that could potentially be a bottleneck. The goal of GPU-driven rendering is to put all of this CPU code on the GPU as well. So we have no bottleneck on the CPU anymore. The minimal system requirements for Cubyz currently are OpenGL 4.6. But apart from that, you can use any hardware basically. This is like my computer has an integrated GPU and that's running great. So I think the first thing that we need to do is right now we are setting a bunch of uniforms for each instance, and in order to use multi-draw we need to we can't have uniforms be different for each instance. Uniform need to be uniform for all of our draw calls in the multi-draw. And because of that, we have to find another way to put these onto the GPU. And the solution for that would be to use a shader storage buffer object. And yeah, I'm going to set that up real quick. Yeah, exactly. Uniforms need to be uniform. So we need these three things on the GPU. Huh. Where's this defined actually? Okay, it's defined down here. So the idea is basically to put all of these values into one giant buffer. How do I do this? Just making sure it's aligned properly. Yeah, now we can just make the SSPO for the GPU. This large buffer thing here handles like allocations and stuff. So we can, like, for each chunk allocate a small bit in that buffer. This begin and end render here is doing some synchronization. Yeah, compiling Cubyz for ARM should be relatively easy, but so far not many people have ARM CPUs, so, and I don't have hardware to test it, but in theory it should work. There might potentially be a few issues because ARM is a little bit different, but it should work fine. Alright, next up I need to upload the data. I think the best location is down here. So this sub allocation basically tells it where the at what index the data is allocated, and we need to store that somewhere to later tell the GPU where our chunk is located. Yeah, and now I can just upload all the data. This is the world position of the chunk. So, and the rest can be done in the shader. Now we need to find a free binding slot. Okay, there's a question. Instead of potential Vulkan rewrite in the future, what do you think of instead using something like an abstraction layer that can use any API as a backend, like Mark GPU? Yeah, honestly, I prefer working with lower level APIs. So I think I would prefer using Vulkan over something higher level. Also, the Vulkan rewrite I think is not that difficult. So maybe a month of work or something like that. I think the making the Vulkan triangle took me like a couple days or so. Anyway, so right now it's yeah, it's complaining because it has the same binding, and now we need to find a free binding slot. I will do that by just grabbing through all my shaders and check which bindings I have. Okay. It's looking like 6 is free. Oh, just a quick check. Okay, it doesn't compile. Of course it doesn't. Okay, looks like it's working fine. So yeah, the next step would be to use this data instead of setting the uniforms. For that we need to know which chunk we are in. And there was actually a little trick that we can use. I think there is a draw instanced base vertex. We also need the base instance, I think. Yeah, this one. Here we go, long command. The basic idea is that we can pass the chunk ID through the base instance, which is not used for anything else. Okay. I guess I can do that. Is that enough? Or should I make it even bigger? Okay. Okay, great. So yeah, I want to use this super long command to pass some extra info to the GPU. Let's see. There's a ton of stuff. So far so good. Instance count is 1 because we don't want to create multiple instances of each chunk. The base vertex stays the same. And then in the base instance we can pass the chunk data basically. And then in the shader we can get the chunk ID as GL base instance. Is that a thing? No, it's not. It is instance ID, okay. And I need to do the same thing for transparent rendering. Alright, let me see if it actually works. Yeah, basically I'm just using a longer command to do the same thing. It shouldn't actually change anything. Yeah, it looks like it's running basically as it did before. As expected, so I did not make any mistakes here. So the next step would be to use the data on the GPU. So can basically get that from the chunk. Like this. Huh. Seems like everything turned invisible. That is not good. Time to open render doc, I guess. Okay, it seems like... Okay. So... let's see... There must be a way where I can see which buffers it's using. Oh. Could it be this one? 25 million bytes. I have no clue which of these buffers it is, so I'm just going to check all of them. That's not the one. That's also not the one. Huh. Huh. That's weird. It must be one of these. Oh, I think... think it might be an alignment issue. Okay, no, that's not it. Okay, this one is looking like the index buffer. Yeah, this one must be it. I try running it again now that I have... Oh. Okay, that did something. Huh. That is weird. GPU-driven rendering means that I do more stuff on the GPU. Like currently the CPU creates one draw call for each chunk, and in GPU-driven rendering the GPU would generate all the draw calls and the CPU would basically just use one command to start the GPU. Okay. Oh, I think I know what's going on. Yeah, the problem is that vectors in SIG are headed to like the newest power of 2. So I guess we have to do the good old XYZ. Okay, now it works. Although actually it doesn't. You can see that it's like flickering at some positions. That's because there are yeah, sometimes there's some overlapping meshes and z-fighting. So yeah, it didn't upload the right thing to the GPU, I guess. Yeah, here on the left you can see that there is an LOD chunk that gets painted on top of the normal chunk. And the visibility mask is supposed to remove like this one quadrant. Huh. That does not look right. It still looks shifted. Huh. $20. What are your future plans with this project? Will it be open source? Will you sell it or Steam? What will the gameplay look like? Okay, well, the game is already open source and I don't plan on selling it, so it will probably stay free for everyone. In terms of gameplay, well, I guess I would like to have a focus on exploration and like exploring the world, finding cool structures, and yeah, fighting through dungeons and all of that. But that's still way in the future. But well, right now it's the current state is that you kind of have like a creative experience where you can build stuff. I do wonder why it's shifted like that. Oh. Oh, I think it is because of alignment. So I do need to align it to 4 bytes. Huh. Wait, what? Why is the... Can I not align it? Oh. Oops. Okay, now I know what's going wrong. I need to align it to 16 bytes, not 4 bytes. And I guess I can go back to the thing I had before. With the vector, so that should work. Well, I guess it doesn't work. Okay. Ah, I see. That is weird. It's still shifted. I guess I'll temporarily just do that. That should give it the same alignment. Here we go. Still has the wrong data though. base instance 147. So it's this one. Huh. That is weird. What's your stance on languages? Like, would you use a library that is made in a different language if it was beneficial for Cubyz? Or do you only consider using Zig libraries? Well, I'm using tons of C or C++ libraries already, like glFW, FreeType, halfbus, port audio. So I'm already using other libraries. Of course, the library would need like a C interface or something like that, so I can easily integrate it into Zig. Yeah, well, you cannot use C++ libraries which don't have a C interface. Like, it needs to have a C interface. But yeah, I can compile the C++ libraries and use them through the C interface. Okay, wait. Okay, that's looking better. I guess if the Rust library has a pre-compiled binary, then I could. The thing is, I don't want to add additional dependencies to the compilation process. Like, I don't want people to have to install the Rust compiler to be able to compile Cubyz. That would be a bit too much. I didn't scroll on my chat. It's just there is a delay between what you see in your chat and what I see in my chat. Yeah, the thing is that Cubyz is really intertwined with its network protocol implementation, so that might be difficult. But it definitely would be interesting to see if it's maybe more efficient or something like that. I think the delay is mainly for efficiency, so YouTube can do some more stuff on their servers or something like that. If I stop the stream right here, then you will see everything up until the moment that I hit the stop button, I think. So it cannot really be used for something like that. Okay, the question now is why Why is this not working here? Huh. It seems like it's not reading the right value or something. So, okay, we will now print the color of this. Can you give a brief explanation why did you go from Java to Zig? So, well, it's a little complicated, but I was kind of annoyed by Java's inability to write performant code, like, or to write good-looking performant code. Like in Java, you can, if you define an object, then it will always be a reference and it will always allocate memory, and that makes it kind of inefficient. So you either, you basically have to use only primitives or only arrays to make fast code in Java. And that's one of the reasons why I switched to Zig. I was also kind of getting annoyed by having to tell everyone who wanted to test the game that they need to install Java and that they shouldn't install Java 8, that they should install something newer, and that was kind of getting annoying. And honestly, I think Zig feels much better to program in than Java. Mojang solved these problems by just shipping the Java runtime environment with the game. And well, that's kind of big. And yeah, they solved the performance problems by not worrying about performance, I guess. Also, I think back in the day it wasn't as big of an issue. But right now, if I go and search for download Java, then the first thing that we get is this thing here, download Java for Windows. And it takes us to a page that that only has Java 8. Right now the version is maybe 22 or 23 or something like that. And this is a really old version. But it's still the first search result, and that's where many people get confused. Hmm. Hmm. Oh, I made a mistake. Okay. Hmm. You could send 20 minutes into the past. That's weird. Okay, this chunk has voxel size 1. So in theory, this should say 1, but it says 32. That's not good. Alright, let's see. It is at 689. $689. Here we go. Huh, here it says voxel size 1. Wait. I think I'm using the wrong one. Yeah. Should be this one. Okay, well. Huh. But why? Oh, it's a float, okay. Well, I don't care. Undeclared identifier? Oh, I guess. Okay, that looks better. Here we go. Actually, let's keep this. Hmm. Looks like it does change something. Huh. Okay, the visibility mask is still incorrect. Maybe I'm uploading in the wrong location. I guess it's only searching in the ones I have open. No. Where's the visibility mask getting updated? Oh, okay, I think, yeah. This value is updated every frame. Yeah, Linux Mint. Okay, so this value is getting updated every frame, so I guess we need to upload the data every frame. It's kind of inefficient at the moment. We'll take care about this later. All right. I guess I should I guess I should remove my debug code. Alright, here we go. That is looking good. Finally. That took longer than expected. Alright, now we can get the other values on the GPU as well. The voxel size can go. Okay, I guess. Okay, yeah, I'm also setting the same uniforms in the transparent render path. Huh? Ah, okay. This code here is for rendering the it's for rendering the block preview textures. But we'll take care about that later. Okay, it still seems to work here, and the item textures are broken as expected. So now I just need to take care of the position, and the position is a bit difficult because the player position is I want to make the game work even at high coordinates. So what I did here was make the position calculation in floating or in double precision to avoid precision issues. But if I move this over to the GPU, then I can't do that because the GPU doesn't support double precision, or at least not by default. And it's also really slow, so I don't want to do that. So what I'm going to do instead is send the integer and the fractional part of the player position to the GPU in a uniform. Okay. And that I need to quickly check if there's a built-in for that. Could I use a mod? Okay, it's integer only. Is it integer only? Let's see. Okay. Alright, mod with a 1 seems to work. Renderer 186, here we go. And here. And 224. Yeah, like I said, we will take care of this later. So I will just comment out the thing. Okay, that seems to work. Now I just need to make the corresponding shader code. That is a vec3i. It's an ivec3. And that's a vec3. Okay. So it's this minus the player position. Chunk ID position minus position integer minus player position fraction. Okay, here we go. And as expected, it still works. Great. Now I guess we can clean up all that stuff. No. Can we remove that? We can remove that. Can remove that. And we can remove that. All right. And it still seems to work as usual. Oh, okay. What is happening there? Why is there a plane of water flickering? What is this? Oh no. Oh no. Yeah, typical synchronization issue, I guess. The ocean is missing. Oh, there we go. Where is it? Okay. Let's see. No, nothing is broken. It's working as intended. It's not a bug, it's a feature. Alright, here we go. Whoa. Base instance 0? Base instance 0? Huh. That is surprising. Alright. That doesn't seem too problematic. Oh wait. Right. I'm not uploading, I forgot to upload the I need to upload the chunk position in both cases. Like I was only uploading the chunk position for opaque meshes. or chunks with opaque meshes. So let's try that again. Uh-oh. That's not looking good. Huh? What? Oh, I should probably also make the terminal bigger. Huh? Huh? So now it's working? Why was it giving me this weird error before? That is weird. Anyways, it seems to work. And it seems like the performance is basically like it was before. The FPS jumps around so much because I'm streaming, and yeah, the streaming messes with the game. Like without streaming it looks smoother. I probably shouldn't make a stream where I do stuff where I need to actually look at the performance. So what happened here? the sidebar is broken. Ah. Here it works. Okay, now it works. That is weird. What graphics card do you have? I have an integrated graphics card. And my CPU is this one. Yeah, now it works, but before it wasn't rendering anything. Like it was clear, this entire thing. But now that I click to another tab, it's working again. Alright, anyways. It's looking like we have done everything we need here. Just quickly double check. Alright, so here we have nothing. Upload chunk position, okay. And yeah. Okay, so we only have the draw call in here. So now I wonder, can we? Okay, now we can try transitioning to glDrawIndirect. Would you recommend Zig for game dev? Did 0.12 fix the compiler bugs? Well, I don't know, I would recommend to just give it a try and see for yourself if it's working for your purposes. And, well, 0.12 certainly fixed a ton of compiler bugs, but not all of them. Alright, in order to draw this indirectly, we need to put the corresponding data onto the GPU, I guess. And for that we basically need, I think we need the start and the vertex count. Yeah, I agree. It's my integrated GPU is pretty decent. Two ads, seriously? I put it on like, yeah, it's put on conservative ads, so it should give you few ads, or at least it's supposed to give you few ads. You already had two. Well, I guess we have been streaming for quite a while. So let's see. We need all of this. first index, base vertex, base instance. Yeah, I would really recommend Zig for that use case. It's basically, in a way, a higher level version of C, but not as high level as all the, or, well, but also kind of lower level in some ways. It's pretty good, in my opinion. Aha. Oh, wait. It's not so easy, actually. Each chunk has two meshes, so I need to store the data for both of them. That is the one, okay. No, times 4. Alright, times 4. Vertex, count opaque. That one is just this. Okay. Also, these were uints, I think, yeah. So I'm quickly checking if everything still works and the alignment is still correct, just to be sure. And then we can start filling the indirect buffer. For that we will use a compute shader. For now, seriously? There's no way to get... Okay, now they are gone. No! Maybe if I name it CS. Okay, that tries to make it C#. Huh? I guess I'd turn off notifications. No. Well, I guess I have to live with these annoying notifications. So anyways, we need the chunk data in here. And then basically we want to write to another buffer. Alright, I'm going to create the indirect buffer real quick. It's another shader storage buffer. I'm also going to use the the large buffer here to get some allocation. Otherwise I would have to worry more about synchronization. Init. Okay, we need a new binding. One, two, three, 4, 5, 6, 7. Okay, I guess we need to use 8. Okay. Alright, for now I will use this as a uniform, but somehow we need to know the chunk ID. Later it probably makes sense to insert these in bulk and do multiple at a time. So I also need to know where to insert the command. Wait, I think it's like this. Alright, the count comes from the chunk data. ID dot count. Let's do the opaque ones first. Then instance count is 1. First index is the start. The base. Wait, no, that's. Wait, what is first index? Huh? Ah, okay. Okay. That can be 0. Yeah, that is the first index is 0, and the base vertex is the parameter we added before, and base instance is the chunk ID. To give the chunk ID to the other shader. And I guess we use a transparent index. What am I doing? I guess I'll just do a boolean for now. Probably makes sense to distinguish between these. Is transparent, else vertex count transparent, vertex start transparent. Alright, now we have a compute shader that takes the chunk index and puts the draw command into a command buffer. init compute and get uniforms. Alright, command uniforms. Okay, now I just need all these uniforms. Now, in theory, if I call that shader, like every frame, then we should be able to populate the indirect buffer. How did I... Okay, let's call this command buffer. I think that makes more sense. Yeah, that was me. I should probably close Discord here. Command buffer. Your headphones just stopped working. The others can still hear me, right? Okay, I want to make this one public. Alright, now can use war. Okay, I need to make it public, of course. So for now I'll just allocate one slot in the command buffer. And then we can now I do need to look up how to do the command dispatch again. I think I had it here somewhere. Okay, GL dispatch compute and a memory barrier. Ooh, this will be expensive. But it's all only temporary. And I can also now initialize all the uniforms. Chunk ID is this one. Command index is from the allocation. And then is transparent is false. Alright, and then we just bind the shader again. So this shouldn't do much. Oh, forgot something. Command uniforms. Alright. Ooh. Huh. Line 41. Aha. Wait, what? Ah, okay. I think that should do it. Invalid operation. Okay, that is a uint, of course. How much RAM should a 16 by 16 by 256 chunk mesh take? I have no idea. If it's all air, then it's going to take no RAM at all. It all depends on your terrain. Alright, now the moment has come where we can try drawing the thing indirect. Alright, how does this work? We need the mode, GL triangles, we need the type. Alright, let's do the mode first. Specifies the type of data in the buffer bound to, okay, that is unsigned int. And now specifies the address of a structure containing the draw parameters. Okay, we need to bind it to glDrawIndirect buffer. Indirect is interpreted as an offset. Okay, great. Alright, and this is then a offset. And that would be our allocation start. So this should in theory work. Huh, it actually works. Okay. Can it be this easy? Okay, yeah, it's using DrawIndirect. Huh. Wait. Alright, that's indirect rendering. Okay. So next up we need to do the same thing for the transparent meshes. Oh, we also need to free that. Now I would like to know how big the memory usage is for the command buffer. So I'm going to add that to the debug screen quickly. Size. Guess I'll just copy all that. Size. How did you get the idea to stream? Well, a couple of people were asking asking for it, basically. So I decided to give it a try. Okay. Alright, I guess memory usage is 0. Hmm. Alright, so now we need to do the same stuff for the transparent meshes as well. So another compute path. We need the transparent shader. Need to find the buffer again. And that should be it. Seems to work fine. Just want to quickly verify that it's actually using the indirect command. Alright, it's using indirect rendering for the water as well. So I guess the next goal would be to use multi-draw. And for that we need to put the draw command on the outside. So in here. Here where it says render. Alright, I guess we need a list of chunks. And then we call that prepare rendering, I guess. Prepare rendering. Actually, we only need the chunk ID. Huh. I guess we do that as well. But in theory, that should be it. So next up we need to put all of this stuff into the buffer. Chunk list. I think we need another buffer to tell the GPU the chunk IDs of all the chunks it should work on. Oh, so many buffers. Chunk index buffer 32. Alright, I think 9 is next. buffer dot upload data. When will you add monsters? Well, I don't know, but first of all, I would like to improve the rendering performance a bit. And I also want to make collision detection for the player and do a couple of other things to catch up with the features that the Java version had. And yeah, there's also the potential Vulkan rewrite, which might happen, I don't know. Monsters are a waste of draw calls. Well, hopefully with multi-draw they won't be. Chunk IDs. Chunk ID index. Give in chunk ID equals chunk ID IDs add chunk ID index. Okay, so now that we need to do multiple at once, it probably makes sense to start using multiple threads. Global invocation ID. What does that do exactly? Aha, okay. It's workgroup ID plus local invocation. Okay. So that is the one I want. Plus that one. Okay. And yeah, I guess So yeah, with these changes it should be able to do everything in parallel. Now I also need to give it a size so it doesn't overshoot. That should work. All right. So I just renamed them. Alright. Now chunk ID index is chunk ID allocation start. Command index, no, it's command index start. Is this one, and size is the length. Alright, and now we dispatch compute. So we can copy the code from here again. All right. And now glMultiDrawIndirect. Triangles, unsigned, int. And now what are the other parameters? glMultiDrawIndirect. That is the offset pointer. That is... what did we have before? Okay, this one. And the next one is draw count, which is again the length of the chunk list. And the last one is divide. If divide is 0, then the array is assumed to be tightly packed in memory. That's what we want. And let's see if it works. Command shader is not marked public. Alright, we can change that. No field name chunk ID. Oh, I guess we have to fix the transparency. chunk ID index. Well, yeah, let's comment out this stuff here first. I'll take care of transparency in a bit. Just want to see if it works. That's not good. Invalid operation. That is not good. No buffers. Okay. Alright, I can fix that. Still crashing. How do you feel about AI training on your GitHub open source repos? Well, honestly, I don't really care. Like at the moment there's, well, AIs can't really make sense of Zig anyways. Because there's way too little training data. Huh. Oh, I guess I should probably check if there are no chunks. And of course it's still crashing. Okay. Now we see nothing. I guess it can't always be easy. Let's see, glMultiDrawIndirect indirect 15. Oh! There's an error. Where can I see the error? Okay, here we go. No vertex shader bound at draw. Alright. Of course, I need to put that here. Alright. Well, I guess it's working as intended? Yeah, looks pretty good to me. So would you like to play the game like this? Oh, could it be? Alright, let's check the buffer maybe. It has an offset of 980. Could this be the right buffer? No. This one maybe. Okay, that's looking correct. Alright, we are starting at 980. There's nothing there. Wait, I think... That's not good. Why is it starting at 980? Is that the right parameter? Wait. MultiDrawIndirect. The first parameter is the indirect pointer. And that thing is this one. Oh wait, is it bytes? I think this is a byte offset, so we need to divide by 20. That is 49. Okay, I guess that makes more sense. And then it goes for 25 elements, so up until 84. Alright, I'm just going to try adding a barrier maybe. Maybe here. Not sure how this works. Okay, that didn't help. Alright. I guess I'll have to look at the compute shader call again. So what are the uniforms? Size is 25. Start is 49. Okay. And start is 49 and we go to 74. Okay, it seems to have filled in all of these in order. Take a look at this buffer. 118. Looks pretty normal. That is suspicious. Why are these the same? One 118, 119. Yeah, these are the same. They have the same data. And yet they are being rendered. Okay, I guess it's rendering the same chunk twice. Yeah, it's exactly the same chunk. What a great day to move more stuff on the GPU. Well, what a great day to get some databases on the GPU. Huh. Okay, the first chunk seems to be stable. Wrong offset. Wrong offset of what? You mean this one here? But why would it call the others wrongly? Like, shouldn't then everything be wrong? Well, I allocated inside of a bigger buffer. And then I fill it with a compute shader.